Okay, guys, so this is the last lesson of chapter 8, section 8.6. Unfortunately, that also means that it's one of the harder lessons of the chapter because it summarizes a lot of the information you already know and then extends it a little bit. So it's not too bad, but it's quite a bit of a increase in difficulty, I think, from previous sections. So it's also a fairly long section, so I'm going to try and cover just certain examples to help you get through this without spending 3 hours on the video. Yeah, and I hope that you will take the time to work on this carefully, and then maybe on Friday during our conference time, you can ask me some questions if you have any, or even Wednesday if you really want to. Okay? All right, so our task today in section 8.6 is to translate and classify conic sections. So we've been working with all of our conic sections centered at the origin. Now we're going to work with conic sections that are not centered at the origin, okay, that are translated, as this title implies. So we're graphing all of the conic sections translated, and then we're writing all of the conic sections equations after they've been translated. And then we're going to identify symmetries, classify conic sections. Okay, it's quite a lot going on there. The symmetries are fairly easy, but that implies that you already know, you already understand the conic sections fairly well. Okay, so we worked with, and I suggest you write down for yourself the equations of all the conic sections we've worked with so far. So maybe you can write here like previously, and then write down all the conic sections. So circle for us was x squared plus y squared equals r squared. Parabola for us was two forms, either y squared equals 4px or x squared equals 4py. And then an ellipse also had two forms, x squared over a squared plus y squared over b squared equals 1. Or the same thing except the a was under the y and the b was under the x. Okay? And then hyperbola, also similar idea. We had x squared over a squared minus y squared over b squared equals 1. Or we had y squared over a squared minus x squared over b squared equals 1. The hyperbola is a little bit different from the ellipse. See, for an ellipse, the x is always in the front, and for a hyperbola, the x and the y trade places. Okay, and they determine which way the transverse axis goes. All right. So this was everything we've done so far. Basically, a little summary right there of chapter 8. Now we're going to look at translating the conic sections. But so for us, for all of our conic sections, the origin or the center of all of these was 0, 0. Okay, and so you can imagine it's like writing, if you look at this circle here that has the center HK, and if the conic section is a parabola, then we call that point the vertex, not the center. But if the center is HK, then the circle equation looks like this. Okay? Now, if you think about that carefully, then you'll see that it actually works for what we did before. Before we said that our conic sections equation for a circle at least was this. But if I plug the center coordinates into this formula, it actually gives me this equation. Okay, so if I do x minus 0 squared, and the 0 is this 0, x right here, okay, which we call h, plus y minus 0 squared equals r squared, you know that that's the same as this. Okay, so actually we have been working with these equations, but we just had 0 for x, 0 for the x coordinate of the center, and 0 for the y coordinate of the center. And so all of the equations, if h and k are consistently 0, they look like this. Okay, so actually we have been working with these equations already. We just didn't write them like that, but you really have been working with them already. Okay, so long story short, and you've known this from chapter 1. We're now in chapter 8. From chapter 1 we said that the letter H is associated with horizontal translation, okay, and the letter K is associated with vertical translation. Okay, so if I go and add an H and a K in the parentheses next to my X and Y in the circle, what it does is it translates the circle H units left or right and K units up or down. Okay, and it's the same here, and it's the same here, and it's the same here. H and K are responsible for, H is responsible for horizontal translations, K is responsible for vertical translations. If H is positive, translate to the right. If H is negative, translate to the left. Okay? And so I don't really think that it's necessary for me to spend too much time on these formulas. I need to check something, but I think that we actually end up giving you the formulas. Let me see something real quick. I'm going to bring up the test for myself, of course, not to show you. But I think that we may actually even give you the formulas. Let's see. For the... Oh, no. Oh, no. No, we did not give you the formulas. Never mind. But in any case, I think if you already know these formulas, okay, if you already know these formulas, then coming up with these are not too hard. Okay, you just add an H or a K next to the X or the Y in parentheses squared, and then you have the translated formula. Okay, so I don't want to harp on about this too much. I'd rather just go in there and show you some. So you do need to know these. We're not going to give them to you on the test, but the place I think I remember us giving them to you was maybe the final exam, I think. But in any case, so yeah, you do need to know them, but it's not really a lot of memorization because you should already have this in your head. Some of these equations we derived together, so you should know them. Okay? All right, so without going on about this anymore, I'm going to jump in and just do some with you. Okay? So, example 1 says graph the equation of the translated circle. This is very simple. I'm not going to do 2. I'll just do 1 and we'll move on. Okay, so graph the equation of the translated circle. So the way you do this is you identify the center. Remember, the center or the foci or the vertex or all those kind of things are super important for conic sections. So, and all of them do really have a center, and then they have the other features of the conic section. So the center is where you start. So you say to yourself, okay, this is x minus h squared plus y minus k squared equals r squared. So knowing the formula helps me immediately to know the features of this conic section. So I know that h must be 2, okay, and h comma k is the center, okay. So then I know immediately that h is 2, and k, if you look here, this is y minus k, but this is positive 3. So k here actually is negative 3. It's the opposite sign. Because in order for me to get y plus 3, I need to substitute negative 3 in for k. Alright? So hk is 2 negative 3. And I also got this. R squared is 9, so the radius is 3. Okay? Now, if you take the square root of this, you get plus minus 3, but radius is a distance from the center. So that measure is always positive, so we just say it's 3. So to graph this, I just do go to the center, which is 2 negative 3, and plot the center. You can label it C for center, that would be good. And then the radius is what determines the entire circle. So I go 3 units this way, 3 units this way, 3 units this way, 3 units that way, and that gives me the circle. And please don't worry about ugly circles. Okay? Okay? So there you go. Find this center, use the radius to draw the circle. Very simple. Very simple. Alright. Example 2, graph the equation of the translated hyperbola. Okay? So, two different examples. I don't think that there's any difference in difficulty in either of those. But let's do this. Let me write the standard form y minus k. Remember, y goes with k over a squared minus x minus h squared over b squared equals 1. And then if we have this, then we can see, 3 is in place of k here, okay, and h negative 1 is in place of h, okay, because again, to get plus 1 over here by substituting a number into this equation, I need to substitute negative 1 in there, then I get x plus 1, okay. So what I see is, from this, I see that k is 3 and h is negative 1, okay. And then I also see a squared here is 4 and b squared is 9. Okay, so that's not any different from what we've done before. The only difference here is the k and the h. Alright? So to graph this, I do the same exact procedure, except I don't start from the origin, I start from the center that's been translated. Okay, so center is the first thing I have to find. So the center is h comma k, and we're saying the center, based on my equation up here, is negative 1 for h and 3 for k. Alright? So you can draw your center straight away. Negative 1 and 3, there's the center. And I would write C for center there. Okay? And now we follow all the same procedures we did before for graphing the hyperbola. Okay, so if this, we can label this step number 1 was to graph the center. Step number 2 would be to find, for a hyperbola, you'd want to find the vertices. Okay, which come from A. A is associated, the letter associated with the vertices, and again, this term being in front of the minus is the term that determines the direction of the transverse axis. So a squared is 4, that means that a is plus minus 2. The vertices are 2 units away from the center, okay? So, again, be careful, just like we did before, but before our center was here, and I went 2 units this way, 2 units this way. Well, now the center has moved, so the vertices are 2 units away from the center, and they're 2 units away from the center in the y direction, because y is in front of the minus. So I go up 2 and down 2, okay? And these are my 2 vertices. So this is a vertex, and I want to label this, but I don't want to label it incorrectly. I'm going to move this label over, not like that, sorry. I'm going to move this label C here. I'm going to move this to the side. Oh, that's not doing what I wanted to do. How about I just erase it and do it again, okay? I'm going to put C here, and then I want to put vertex here and vertex here. You want to label each point so that you understand what they are, okay? And so that's fine, I did that. And then number 3 would be use b squared for the other point for your hyperbola to make the box to draw the asymptotes, okay? So this is not a covertex, it's just called, I'm just calling it the other points that help you make the box, okay, to draw your asymptotes. So b squared, we said, is 9, that means b is plus or minus 3, which means, again, from the center, please, from the center, this means go 3 left and right from the center, okay? And those points help me make my box, okay, to draw my asymptotes. So here is the box that I end up with. Something like this. Okay. And that's really all I need to draw the hyperbola branches. I'm still missing something, but that's all I need to draw the branches, really. So I know now that because these two are vertices, okay, I know that the transverse axis is here, okay, and I know that I can draw my asymptotes and draw my hyperbola at this point, okay. So I'm going to erase the transverse axis so you see the vertices. So let me use another color. Maybe let's use blue. And we'll draw the asymptotes. Okay. Asymptotes go through the corners of the box. The asymptotes go through the diagonals formed by the box. Okay, something like that. And then you can draw your branches. So from the vertex, you draw your branches, okay? And again, your branches should be approaching the asymptote more and more closely. That's not the best, but it's good enough. And then something is missing on my graph. Something is missing on my graph, okay? And that is the foci, okay? So number 4, we wrote... In my completed note sheet, I wrote that the transverse axis is vertical, okay? So actually you can write the transverse axis here would be this axis right here, okay? But let's just say vertical transverse axis, okay. All right, and then 5 is to find the vertices. If you were going to number these steps, which I did in my completed note sheet at least, find the foci. All right, and foci are associated with letter C, which I don't have C anywhere here, but we have a formula for this if you remember. The formula for a hyperbola has a minus in it, so the corresponding almost Pythagorean theorem formula here is c squared equals a squared plus b squared. That's the Pythagorean theorem, but that's not. It's probably where it comes from, but that's not what we're calling it here necessarily. Okay, so c squared equals a squared plus b squared. So to find c squared, I just plug in a squared, which we said is 4, and b squared we said is 9. So c squared is 13. So that means c is, if you take the square root, plus or minus root 13, which is approximately plus or minus 3.6. Okay? And what that means is, again, you go 3.6 units away from the center on the transverse axis. Okay? So foci are inside your hyperbola. Foci must be here and here because they must be embraced by the hyperbola or be in the middle of the hyperbola. So, and they're also on the transverse axis. So 3.6 from the center again. 1, 2, 3.6. That put me maybe up here somewhere, and we can label that focus. And then 3.6 here. 1, 2, 3.6, maybe down here, and call that a focus. Okay. And at that point, you're done. There's nothing else really you can do to graph this. All right? Okay. That's tough. I think that's tough. So I wonder if I shouldn't do another one. Let me see. I think let me skip to the next example, and then if you have questions, you can ask me. Okay. So. Example 3 says, oh, no. So I will do this one. Because example 3 jumps to something else, okay? So let me do example 2b, and then I'll do example 3. So example 2b is another hyperbola. The way you know that is a minus here. That's the only conic section we have. There's a minus in the standard form. And look at the equation, make sure it's in standard form. It is. And so now I can identify components of the formula. This is h, this is k, this is a squared because it's in front of the formula. It's in front of the minus, and then over 1 here is your b squared. Okay, so be very careful. The center is what I need to start from. Okay, as you remember here, the center is where I start, and then I draw all the other things from the center. Okay, so find the center first. Now just be careful, this is a common mistake for students. H is actually -2 because to get a plus 2 from the formula, I have to substitute in negative 2 there. Okay, so h is negative 2. But now we have okay. Let me just continue, and I'll show you. There's another problem going on here, and k. So h comma k. K is 1. All right, that's fine. Center is fine. No issues there. But I have another problem. I said if you look at this and compare it to the standard form formula, then you see things happening. But this is not standard form. Careful now. Must be equal to 1. So all our ellipse and hyperbola formulas are equal to 1. Okay? This is not equal to 1. So I need to make it equal to 1. Now for the center, that's not going to change anything. But for the rest of it, it will change things. So what I have to do here is say, I'm going to erase this because right now b squared, I was about to write b squared is 1. You divide this by 4, you divide this by 4, and now you get this weird thing where you're dividing by 4 here. So dividing by 4 is the same as multiplying by a fourth. Don't write divide by 4 here. You're dividing the numerator by 4. Okay, that'll just confuse you terribly. So, or you can think about it as multiplying by a fourth, multiplying by a fourth, multiplying by a fourth. Maybe that's easier for you to visualize and not get messed up here. Okay, maybe I'll write it like that. Okay, and so multiply by a fourth, then this would cancel and become 1. So my new equation, I probably should write this over here. My new equation would be x, not x squared, x plus 2 squared over, and a fourth times a ninth is a 36th, okay, minus, and then this one would just be y minus 1 squared over 4 equals what? All right. Big problem here was I almost did this question without putting it in standard form. Cannot be equal to 4. Ellipse hyperbola equations must be equal to 1. All right. So that's what I have. As you can see, the center didn't change, fortunately, but b squared and a squared oh, sorry, that's not b squared. A squared and b squared definitely did change. Okay, they're definitely different numbers. Okay, so draw the center, negative 2, 1, which would be here. Okay, label it center. All right, there's the center. And then now I can start using the other features of the equation to draw my hyperbola. Okay, so a squared is 36. So we know that the term that's in front of the minus is the term that determines the direction of the hyperbola. In this case, because x is in front of the minus, it's a horizontal hyperbola, and then 36 is a. So a then gives me the vertices. So the vertices are a squared equals 36. A is plus minus 6. Okay, and again, you have to understand that because x squared is in the front, this is a horizontal hyperbola. The transverse axis is horizontal, so I'm going from the center 6 units left and right. From the center, 6 units left and right. So 1, 2, 3, 4, 5, 6. There's my one vertex. Okay. And then I go 6 units the other way. 1, 2, 3, 4, 5, 6. There's my other vertex. All right. And now, please, you should know, because the x term is in front of the minus sign, you should know that what's going to happen here is branches like this. Okay, branches like that. All right. And so then I use, for the other points, they're not co-vertices, they're just other points at this point. B squared equals 4, and that means b is plus minus 2. Okay? And if I use that, again, now I'm going in the perpendicular direction from the transverse axis, so I go up 2 and down 2. And they're not co-vertices, they're just other points that allow me to make the box. I can now make the box for my asymptotes. Okay, and this is a rectangle whose diagonals contain the asymptotes. All right, and let me use a different color again. And now I can draw I should do a different color. And now I can draw the asymptotes, okay, through the center, through the corner of the rectangle there. Okay, and this doesn't have to be exactly perfect, but good enough. Okay, and now I actually have enough information to draw my hyperbola because I have the asymptotes that it approaches. Alright, there are my two branches. It's a horizontal transversal axis because x squared is in the front. And then, so you can say, you know, if you want to, the transverse axis is horizontal. I mean, technically you should be able to write an equation for that. And then the last one would be to find the foci. So I have everything on here except the foci actually are the things that create the conic section. So we draw them last, but they're most fundamental actually to the conic section. So the foci, again, are c squared equals a squared plus b squared. Remember, the sign is opposite of the formula sign. And then you just plug in stuff. So a squared is 36, b squared is 4, and so c squared is 40. So c is plus or minus root 40, which is about 6.3. Alright, so I got 6.3 units from the center. So from the center, 6.3 units. Okay, and 6.3 units are about here, like hard to draw accurately, actually. Just a third of that box. Okay, please, this is the minimum you need to be able to do. You need to be able to show the center, foci, vertices, and how you came up with your asymptotes. If you can draw the asymptotes perfectly without drawing the box, that's also fine, but you need to be showing your work clearly. Alright, so example 3, the reason I didn't decide to go straight to example 3 is a collection of all of them. So you can look at them and go, which conic section is which one, and then draw them. Okay, so I believe the only translated ones I did with you here was a hyperbola and a circle. Alright, this is all 4 of them. This is a big important example. So what I would suggest you do actually at this point is, if I were you, I would pause the video and I would try and graph all of these myself. Okay, I would try and graph all of these myself, and then watch the rest of the video and you can see if you are on the right track. That's what I would do at this point, because this is excellent practice about your understanding of the conic sections. Okay, so do what you feel is best. Okay, so I'm going to look at this, and first of all, let's see if we can figure out which conic section is which. So what's going on here? I have this equal to 4. There's no denominators. So the only conic section we have that has no denominators and has 2 squares is a circle. Okay, so immediately you should recognize this as a circle. So this becomes more important as we go on. A circle has 2 squares, no denominators, and that's how I recognize that that's what that is. Okay. Alright, so I know it's a circle, and then all I need to do is say x plus h squared. Write the standard form here. Not x plus h squared. X minus h squared. Y minus k squared equals r squared. And now I can identify all the components. Again, circles, fairly straightforward. I know from this that h is -1. And I know from this that k is 3. And I know that r squared is 4, so the radius is 2. Okay? And then I can just graph this again. Your center is -1, 3, hk. And so -1, 3 is up here. And then I just use the radius to draw the circle. So radius is 2, so I just go 2 units in each direction from the center, and I can draw my circle. Ooh, that's not the best circle I've drawn in a long time. Okay, So there's that one. Number 2, first your task should be which conic section am I looking at? Well, there's only one squared term, so that's always a dead giveaway. If there's only one squared term, it's a parabola. Okay? So all you need to figure out now is it a horizontal parabola or a vertical parabola? And the way you figure that out is if x is squared, think about our parabolas from way back when in Algebra 1, y equals x squared. This is the parabola you learned right in the beginning, looked like that. Okay? So if the x term is squared, then I know that this is a vertical parabola. Alright? And so regardless, I can still extract the vertex from here. So the standard formula for this is x minus h squared equals 4p times y minus k. Okay? I almost wrote square there. Alright? And that's it. And so from here, I can already get the vertex. Okay? The vertex is at 2, h is 2, and k is negative 3. So this is plus, that means that k is actually negative 3. Okay? So I know that the vertex, since a parabola doesn't have a center like the other conic sections, the vertex is 2, negative 3. Alright? So you can draw that already. 1, 2, and negative 3. And here is my vertex, happiness. Okay? Now, we said it's a vertical parabola, so it either opens this way or it opens this way. Because x is squared, it's vertical. Alright? And then all we need to do to know what, if it opens up or down, is find p. Alright? So I go back here. I remember we had the p part, okay, here. And we said 4p is 8. That means that p is 2. So since p is positive, the parabola opens up. If p was negative, the parabola would open down. So again, because x is squared, this tells me it's a vertical parabola. Okay? And because p is positive, it opens up. Alright? So now I know from the vertex I go 2 units up to find the focus, and I go 2 units down to find the directrix. Okay? This is the directrix. Alright. And so now I can draw my parabola. Now, you technically should draw points. Remember, I actually was very gracious to students about this on the quiz, but for a parabola, to get the shape right, you really need to draw 2 points, one on either side of the axis of symmetry. Remember, for a parabola, the axis of symmetry is the line going through the vertex and also will go through the focus. But you need 2 points really to draw this properly. So if you plug points in there, let's say, what should I let x be? I think, what did I do? If you let x be 0, okay, let x be 0, and you plug 0 in there. Okay, let x be 0. If I plug 0 in here, what do I get? Oof, that's some work. I get 0 minus 2 squared over nothing. Equals 8 times y plus 3. Okay? And if I do that, I get 4 equals 8 times y plus 3. So I get a half equals y plus 3. And so if you subtract that, you get what? Y equals negative a third plus a half. So y equals what, like negative 5 over 2? So negative 2.5. So negative 2.5. Okay? So if x is 0, I get y is negative 2.5. So 2.5 would be there. And then actually you don't need to do another point because you know that this is the axis of symmetry. So I can just use that to reflect the point over here to 2.5. Okay, and so now I have 2 points on my parabola, and so I can draw a more accurate parabola. Okay, something like that. At least you've done your due diligence. All right, so there's the parabola for number 2, and then here is another hyperbola. I'm not going to do that since I did 2 hyperbolas with you already. I'm not going to do that. Let me do number 4, which is an ellipse, which I haven't done one of with you yet. Okay. How do I know it's an ellipse? 2 squared terms, 2 denominators that are not the same, and there's a plus in between. Okay, there's a plus in between. So, and it's equals to 1. There's so many things that give away that this is an ellipse, all those criteria. Okay, so this is the standard form, x minus h squared over, and remember for an ellipse, it's the bigger number that's a, so this is a squared, okay, plus y minus k squared over, and this would be b squared, because that's the smaller number, okay? So what I know is that, I know the center right away. I know that the center is at hk, and h here is 2. That's the x value in the parenthesis with the x. And k is 1. Okay, because that's the value in parenthesis with the y. H goes with k. H goes with x, and k goes with y. And so the center is 2, 1, 2, 1. Okay, right there. That's the center. And please label it center so you know what you're doing. And then from the center, I expand out and draw my ellipse, just like we've been doing in all the other sections. So if you know how to find the center, life is good. Okay, and since this is in standard form, life is even better. So to get the vertices are associated with a squared. And here we said a squared is 16. And in an ellipse, a squared is the bigger number. Okay, and so a is plus minus 4. That means go 4 left or right from the center. Now, why do I say left or right, not up and down for the ellipse? Because the bigger number, a squared, is under x. Therefore, I know that this is a horizontal ellipse, and it has a horizontal major axis. Okay, and so I go 4 units this way. Let me use a different color here. I go 4 units this way from the center, 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, and these 2 things are called my vertices. Okay, again, all of this is happening because the bigger number is under the x squared term. Okay, therefore I know it's a horizontal major axis, and so we call this thing the major axis. Okay, and then I use my other numbers. The co-vertices come from the b squared number, which is 9. So b is plus minus 3, meaning go up and down 3 from the center. So up 3 and down 3. Okay. So those are my co-vertices. Label them, please. And then you can already draw the ellipse at this point. You have enough information. And an ellipse is almost even harder than a circle, I think, to draw. Something like that. And there's one missing piece, okay? And that is the foci, okay? So foci, and here again is a formula. We have c squared equals a squared, but because the ellipse formula is plus, this is minus b squared. Excuse me. And so I get c squared equals a squared, which is 16, minus 9 squared, minus 9, which is b squared. And you get c squared equals 7. So c is plus or minus root 7, so c is approximately plus or minus 2.6. Okay, so that means on the major axis, from the center, go 2.6 units. So 2.6 units, let me zoom in again, is about here somewhere. 2.6 units this way is maybe about here somewhere. Very hard to draw that accurately, okay? So at that point you've drawn the ellipse. All the major information is there. Remember, find the center or the vertex first, and then work your way out from there with all of the conic sections, okay? And that actually is not that bad to draw these, all right? Okay, so example 4 and 5, write the equation of the parabola, write the equation of an ellipse. 6, write the equation of the hyperbola. Notice we're not asking you to write the equation of the circle because that's quite straightforward here, okay? We will do one of those at the very end. So, my suggestion to you again, please, I have this on the completed note sheets written down, is draw a picture. If you draw a picture, it's very hard for you to mess this up, okay? So, I'm going to draw a picture. Here's my x and y axis, and I'm going to draw the vertex, negative 2, 3. There's my vertex, okay, at negative 2, 3, and the focus is at negative 4, 3. So if that's the case, then I know that the picture looks something like this. And then I know that the focus is 2 units away from the vertex. That means the directrix is 2 units away from the vertex, which means the y-axis is the directrix, okay? That's the directrix. Not that that's too important, but then I also know something else. I also know that since the parabola opens left, I know that p is negative 2. Now you can see this algebraically. You can say from the vertex to the focus, I went from negative 2 to negative 4. That means I went left 2, so p is negative 2. You can do it that way too, but I think it's a lot easier to just draw a little quick sketch and go, oh, this distance here is 2, and I'm going left from the vertex. That means the parabola opens left, so p is negative 2. Okay, that's very quick to do. All right. So now that I know that p is negative 2, and I have h and k from the vertex, okay, I can just plug stuff in and I'm done. You just plug stuff in. So you need to know the right form. So if the parabola opens left and right, if it's a horizontal parabola, okay, the term that must be squared is y, all right? So my standard form I use here is this, all right? Y must be squared if it goes left and right, and x must be squared if it goes up and down, okay? All right, so now I just plug stuff in. You've done all the hard thinking already. You're just substituting at this point. So let me do that. Let me substitute y minus k squared equals 4p times x minus h squared. Okay, oh, not squared, sorry. It's not squared, this is a parabola. And then let's plug the numbers in. So p is negative 2 here, so it's 4 times... Oh, I messed that up completely. It is trying to be all fancy. Okay, it is 4 times p, which is negative 2. K from here is 3, and h from here is negative 2. Okay, negative 2. And so if you simplify that, then you get this. Y minus 3 squared equals 4 times negative 2, negative 8, x plus 2. All right, that's my formula for the parabola that meets those criteria. Okay, there's another one. I'll let you do that. Same thing, draw a picture, find p, and just plug stuff in. Okay, find p and plug stuff in. All right, example 5. Example 5 is write an equation of an ellipse with the given foci and covertices. Okay, again, here I think a picture is even more important. Okay, if I were you, I would definitely be drawing a picture here, and for example 6 as well for sure. So what you do here, again, draw the information they gave you. That'll really help you. Okay, so the covertices are 4 and 4, 0. So 4 zeros here, 1, 2, 3, 4. This is a covertex, and then 4, 4. So that would be up here. Okay. Here are my two covertices. I should have drawn that the other way. And it's like this. Okay, fine. Okay, there are my two covertices, and then my foci are at 1, 2, 1, 2. That's a focus, and 7, 2. So 4, 5, 6, 7, 2. Here's a focus. Okay. So now, you have to remember what they gave us. They gave us the covertices and the foci. All right. So what I know now is that this is the minor axis. This would be on the major axis. Okay. And then I know that this is the center right here. So you can at this point count the center. You can read the center off of your little quick rough sketch. The center is at 4, 2. I know the center immediately. The center is at 4, 2. Because there's symmetry here, okay? Because the center is in the halfway between the foci and halfway between the covertices. That's how we drew all of our ellipses, okay? And so I know the center, so I know H and K, all right? And then the other question is, do I know all of the information I need? Well, let's look at the formula first. So what formula do I use in any case? If the foci are in the x direction, then the major axis goes somewhere here. So that means that it's a horizontal ellipse. That means that the bigger number must be underneath x in the formula. So the formula must look like this. X minus h squared over a squared. Remember, for an ellipse, a is always the bigger number. Okay? Plus y minus k squared over b squared equals 1. That's the formula for an ellipse. And because it's horizontal, because the foci are on the major axis this way, okay, because the foci are here and the major axis is horizontal, then the a squared, the bigger number, is in underneath the x term. Okay? And so now we can start thinking about plugging stuff in, but I can't really. I have h and k, so I have these two, check. I have a, not really. A is the foci, okay? A are the a squared, or the square root of a squared, which is a, gives me the vertices. Okay, I don't have the vertices. I only have the foci and the covertices. But this gives me the covertices right here. Okay, so I have b squared, check. And what is b squared? Well, the distance from here to here. Okay, that's b squared. Oh, that's b. Sorry, that's b. So b is 2. I know b. And actually something else. I also know c. C is the distance from the center to the focus. And C, if you count that, 1, 2, 3. C is 3. Okay? So actually I have enough information to come up with b squared, yes, and I have enough information to come up with a squared. Okay? So what you're doing is you're saying, oh, I have this formula. Okay? That formula relates the foci, covertices, and vertices. Alright? So C is 3. A squared I don't know, but I know b is 2 because the distance from the center to the covertices is 2. Okay? And so from this, I can figure out what's going on. So 9 equals a squared minus 4. So 5, is that 5? No, that's wrong. Add 4, not subtract. So that's 13 equals a squared. So that means a is plus or minus. Actually, you don't have to do any more. You stop right there. And you say that's it, okay? A squared is 13 because I'm looking for a squared. So at this point you're done. You have everything you need, okay? And it all came from the little sketch. If you're not doing this with a sketch, that's way, way more abstract and harder to picture. Okay, so now I can start plugging stuff in. Let me go back to green. I'll just plug stuff in. Okay, x minus h. We said h is 4 squared over a squared. We said a squared is 13. Okay, plus y minus k squared. Well, k is 2 over b squared, and we said b is 2, so b squared is 4. Okay, and that's equals to 1. And that's the equation. That's the equation. All right? That is the equation. That's tricky. That's pretty tricky question. Okay? That's a pretty tricky question. All right. So I think what I want to do is do another one actually. I think I want to do another one of this. Example 5. Okay? Example 5, let me do another one. So again, draw a picture, have that in mind, do what they say and see what happens, okay? So covertices, remember covertices would be associated with B, and foci would be associated with C. So they're not giving me the vertices, okay? And just draw the picture. So 1, 2 would be here, okay? So that's a covertex. And then 5, 2 would be here. So covertex here and covertex here. At this point, I already know which formula I'm using, okay? Because the covertices are horizontal, so that means the vertices must be on a vertical major axis, okay? So again, this is a bit of review. This should be called the minor axis, and the major axis is perpendicular to that. So I know the major axis is somewhere there. All right. Now let me do the foci. Foci are at 1, 2, 3, 5. Okay, so 1, 3, 4, 5. So 3, 5 here. And then at 3, negative 1. 3, negative 1 would be over here. Okay, so focus there, focus there. Just like we said, the major axis goes somewhere here, and the vertices are somewhere out here. I don't know where they are, but they're somewhere out there. And we're going to find them in a few minutes. Okay? And so what I have now, I've been given some information, actually, useful information. The distance, this is the center. First of all, I know that. Okay, the center is halfway between the two foci and halfway between the covertices and halfway between the two vertices. Okay, and so the center, I can actually write the coordinates of the center. It's 3, 2. Okay, so we already have the center. We can write that down. The center is at HK, which is 3, 2. Okay, HK. And then from that, I also have other things. If that's the center, which is the only place it could be, then I know that the distance from here to here is C. All right. So what is C? 1, 2, 3. Okay. So C is 3. And then the distance from here to here, covertices are associated with letter B. So the distance from there, B, is 2. Okay. So again, very, very quickly using the picture, you have basically all the information you need to solve the question. So I need to know the formula. Again, the major axis goes this way through the foci, and that means it's a vertical ellipse. Vertical ellipse means the bigger number is under y squared. So the formula looks like this. This is now b squared, okay? And I have this. So the bigger number is under y because the y direction is the major axis. Okay, and then we can start plugging stuff in, but you'll see that we run up against something. What do I have? I have B, so I can plug this in. I have my center, so I have H and K from here, so I can plug that in. I need A. Okay, and how do I get A? Again, same thing. I use this formula, the formula that relates A and B and C. Since I know B and C, I can just find A. Okay, so C we said is 3 from our little picture up here. Okay, C is 3, so 3 squared equals A squared minus B squared, and we said from our little picture up here, B is 2. Okay, so I just get 9 equals A squared minus 4. and add that, so you get 13 again. Is that right? Wow. 13 is a squared. Okay, check. So I have a squared. So now I can plug in all the missing pieces to my formula. Okay, so let me do that. So I have x minus h, which we said is 3 squared, over b squared, and b squared is 4, since b is 2, so 4, plus y minus k squared. K we said from the center is 2 up here, over a squared, which we just found to be 13. And that's equals to 1. So there is the formula for the ellipse. Okay. That's not too hard, but you got to keep your wits about you. Okay. Example 6. Example 6, let's see what this says. Similar thing, but write the equation of the hyperbola. Now, I'm not going to do both of these, because since you've had that introduction to the weird little quirky way this works by drawing a picture, I think the hyperbola part now should be easier for you, okay? So same idea, again, draw a picture, please, and life will be easy, all right? So you can draw a little XY axis. You don't have to label all that stuff. I'm just doing that to try not to confuse you. But you draw a little axis, and then you go, all right, man, that's just increasingly ugly. There we go. Something like that, and you just do what they say, okay? So vertices, and remember, vertices are associated with which letter? Vertices are associated with letter A. Foci are associated with letter C. So they're giving you an A and a C here. And they say the vertices are at negative 7. 2, 3, 4, 5, 6, 7. So negative 7, 3. 1, 2, 3. So here is a vertex. Okay. And then the other one is at negative 1, 3, which is up here. Okay. So there's the other vertex. Okay. And then they gave you two foci. Let me switch the color. Foci. And that's at negative 9, 3. So that's 2 to the left of the vertex here. And then at 1, 3, which is 2 to the right of that vertex there. So this is a focus, and this is a focus. So now you know that your hyperbola looks something like this. Okay, something like that. Don't have to draw the hyperbola, but you know this information now. Okay, and so this is very useful since it's a horizontal hyperbola with a transverse axis here. Then I know that the formula I need to use has to have x squared in front of the minus sign. Okay, because it goes, the transverse axis is in the x direction. It's horizontal. So the formula I have to use is the one with the x squared in the front for the hyperbola. So what you're doing is this. You're saying, I'm using this formula. Oh, not that formula. X minus h squared over a squared. Remember, a squared is always in front in a hyperbola formula. Then y minus k squared over b squared equals 1. Okay, and it's a minus because it's a hyperbola. X squared is in front of the minus because the hyperbola is a horizontal one. All right, and so now I have to fill stuff in. Okay, and we said I've been given an A, so I can fill this in pretty easily, and we can find that stuff right now. I don't know B, and at the moment I don't know H and K either. So I need to work a little bit harder on my picture here. So let's go back to our picture and see what I can extract from this. Okay, so halfway between the vertices, in the middle must be the center. Okay, that's how it works. All right, so the center is there. So what is the center? It is 1, 2, 3 units away here, 1, 2, 3 units away here. So that means that I know that A is 3, okay, the distance from the center to the vertex. And then I can count another 2 units to the focus. So that means if I count this way, I know that C is 5. Okay, 5 units get me there. But still I'm missing some piece of information. What is this? Well, this is the center. Okay, that's the center. And so I probably should write center because I've already have C on the paper here. Okay, this is the center. All right, and what is the center? Well, the center is back 1, 2, 3, 4. That would be negative 4. and then up 1, 2, 3. Okay, so 3. So the center is at negative 4, 3. And that's my H and my K. Okay, so from this I can do a whole bunch of stuff. I have H, I have K, I have A, but I don't have B. So I've got to find B first. So let's go do the formula again, but now be careful. This is C squared equals A squared plus B squared. This is a plus when this is a minus. That's the way you remember that. Okay, and now I'm plugging stuff in, but I know C, we just counted here, from here to here, C is 5. So 5 squared equals, and I know A, which is 3 squared plus B squared. It's the thing I don't know. And so I have 25 equals 9 plus B squared. So if I subtract that, what do you get? 16 equals B squared. And they stop there because I'm looking for B squared for my formula. I'm looking for B squared. I don't take the square root. I always take the square root and I end up plugging it into the formula as a square again. Okay? And so now we can plug stuff in. We know what we need. X minus H. H we got here. That's negative 4. So minus 4 is plus 4 squared. Over A squared. So we said here A squared is 9. Okay? Because A is 3. Minus Y minus K squared. Well, K is 3. Over B squared we just found to be 16. Equals 1. So there is the formula. Okay? Again, drawing the picture really makes this much easier. There are people who can do that in their head very easily, but it's always a risk, especially on an assessment. I wouldn't risk that. I would just draw the picture. Okay? So that's example 6. Example 7 is a little bit strange, but not difficult, just a little bit strange. So I'll go over that with you. Example 7 talks about lines of symmetry, so that you understand, or you're able to at least show clearly that you know where are the lines of symmetry. Okay, so they say identify the lines of symmetry, and I'm not going to do any of these. I'll just do the A, C, E, and G. Okay, I'll do all the A examples since we did all the A examples. So example 1A, identify the lines of symmetry. Here's example 1A, okay, or 1. Identify the lines of symmetry. Okay, so it's a circle. So where can I draw lines that cut the circle in 2 exact halves? Or a line that the circle's halves are mirrored across? Well, okay, I can draw a line this way, and then this half and this half look the same. Beautiful. I can draw a line this way, not like that, on the axis, on that, the line x equals 1, and there we go. Or I could go this way, or this way, or this way, or this, or this, or this, or this. Any line that goes to the center, basically. The answer is any line that goes through the center. Okay? So, that's the answer. You're literally right. Any line through the center, negative 1, 3, is an axis of symmetry for a for this circle. Okay? So you literally write that. Any line through 1, negative 3. Was it 1, negative 3? What was the equation? Sorry, negative 1, 3. Negative 1, 3. Okay? Any line through negative 1, 3 is a line of symmetry. Not an axis. They said line. A line of symmetry. Guys, please, there's a big problem with some of you on your assessments, and in math in general, you don't want to write sentences. You have to write full sentences, okay? This is a very, very basic sentence, but it's a sentence, okay? Any line through that point is a line of symmetry. And you can even say, for the circle. Right? You've got to communicate in sentences, even in math. English is not my favorite, but you got to write sentences. You can't write cryptic clues. Okay? All right, example 2A. 2A, where is 2A? What was 2A? Ooh. 2A was a hyperbola. And I don't think we drew 2A. Wait, where is example 2A? Oh, forgive me for I've sinned. 2A is here, okay? 2A is here. So 2A is here. And question is, what are the lines of symmetry for 2A? Alright, so we say, where can I draw a line that cuts the conic section in half, so that one half can be mirrored across that line to give me the other half, okay? And so you can't do the same thing we did with the circle and just start going crazy. That doesn't work here, okay? But there are more than one. At least you can see if I go, let me use black here. It looks like if I draw this line right here, okay, then each point here can be mirrored across that line. So that would be each point here can be mirrored across the black line. So it seems like the black line is an axis of symmetry. What is the black line? It is y equals 3. Now, guess what? It comes from the center, okay? So the center is the thing that gives you the lines of symmetry. And this is a y coordinate, so you say y equals 3, okay? And then the x coordinate here of the center is 1. And if you look at this carefully, you'll see that if I take a point here, I can mirror it across and find the other point here too. So that also works. And this is an x coordinate, so the equation of that line would be x equals -1. Okay, so those are my two lines of symmetry for this conic section. Okay, so for this one, I said the center was -1 and 3. Okay. This is an x-coordinate, y-coordinate, and since that conic section is a hyperbola, you know that the lines of symmetry are x equals -1, yeah, and y equals 3 for this hyperbola. It's about as little as you can write. Alright? And so if you look at that carefully, it's the transverse axis and the perpendicular line to the transverse axis. But this is okay. You gave me the equations and everything is fine. Okay? Just something to note. An example 4a. What was example 4a? Where is that? Oh, here we go. Example 4a. Well, that is a parabola. And the parabola has a vertex at -2, 3. Here's the vertex. So this is what we would call the axis of symmetry for the parabola. Okay? So the line y equals 3 would be the axis of symmetry. Alright? And that's the only line of symmetry here. So the vertex is at, what do we say? The vertex was at -2, 3. Okay? The vertex was at -2, 3, and it was a horizontal parabola, so the axis of symmetry is y equals 3 for this horizontal parabola. It's not too easy to see if you don't know if it's horizontal or vertical. Okay? And then an ellipse, guess what? An ellipse is very similar to a hyperbola. Okay, even though the formulas are also very similar, the lines of symmetry are also very similar. So if we look at this one, I didn't quite draw the ellipse because that would require me to find the foci, but it's oh, that's not it. Let me erase this. The ellipse would look something like this, something like that. Okay, if you put the foci in. I mean, if you put the vertices in. So what are the lines of symmetry here? Well, it's the minor axis and the major axis. Okay? And those are the two lines through the center. So again, the center gives me the lines of symmetry. So I just say those two. Okay? So the center is, the center here was 4, 2, I think. Okay, was 4, 2, and so it doesn't actually matter in this case if it's a vertical or horizontal ellipse. I still have the same 2 lines of symmetry. Okay, so I have x equals 4 and y equals 2. Okay, so the lines of symmetry for this ellipse are x 4 equals x, or equals 4, and y equals 2, something like that. All right. So that's that. It's harder here because we don't actually have a picture of it. We're referring back to an example at the top, but that's what we did. All right. Very, very long examples here. Okay. We're almost out of here. We have one last example. Well, yeah, it's really one example with 2 parts. All right, and that is classifying conic section using their equation. So classifying conic section using their equation, and then graphing the equation. Okay, so 2 parts. Classify the equation is the first part, and then graph the equation is the second part. Graphing the equation is troublesome because it's not in standard form. So writing it in standard form brings back your old friend completing the square. Oof, uncomfortable. Okay, at least in this case. In this case, we don't have to complete the square. We can see that one. In this case, we would have to complete the square. Okay, to write the conic section there in standard form. All right. So let's jump in here. So first of all, classifying a conic section. Well, actually what you can do is to classify a conic section, just write it in standard form and then look at the standard form and go, which conic section is this? That's one way. That's actually a lot more work than this little recipe, but that'll also work. Okay. Now the textbook way talks about the discriminant and all that kind of stuff, and we completely went away from that because that's not you're not really understanding anything about the equation. You're just memorizing another formula and plugging in some numbers, and so we didn't go that way. We went with the way that you can look at the equation and go, oh, I can kind of see what's going on here, and move on with your life and classify the conic section. Okay, so I'm going to walk you through these steps to classify the conic section. All right, and again, this is not in your textbook, this is on your note sheet. So a conic section can be described this way in standard form. I mean, a general conic section can be written that way. Okay, that's not what we call standard form, but you can write it that way. Okay, and if it's written this way, these steps will help you classify it, so you know what it is I'm working with here that I'm going to be graphing. What is it? I don't even know what I'm looking at right now. Okay, so classifying it, you could do this. You say step 1, if one of the variable terms are squared, if only one of the variable terms is squared, it's a parabola. So this is not a parabola. Okay, done, it's not a parabola. Now look here, only one term is squared, it's a parabola. Done, you know that, that's the standard form of a parabola, right there already. Okay, then number 2, if both squared terms are on the same side of the equation and they have opposite signs, then it's a hyperbola. Both squared terms are on the same side, check. They have opposite signs, no, they don't have opposite signs, they have the same sign, so it's not a hyperbola. If the coefficients of both terms are the same, then it's a circle. This is not a circle. Okay? So, if none of those work, it's an ellipse. Okay, so the 2 coefficients are not the same, they have the same sign, and they're on the same side of the equation, and therefore it's an ellipse. So the steps you want to take is this. This is a process of elimination. Okay, So you're working straight through the steps here. Go through the steps and stop at the criteria that satisfies. Otherwise, you're going to make mistakes, okay? And you don't want to have to memorize more formulas and stuff like that. So, one of them are squared. This one is easy, parabola, you know that. They're both squared and they have opposite signs, must be a hyperbola. If the coefficients of both squared terms are the same, then it's a circle. Otherwise, it's an ellipse. Okay, those are the steps. So we have identified here that we're dealing with this case. Coefficients of none of the other steps have applied, and the coefficients of both terms are not the same. So it's not a circle, so therefore it's an ellipse. Okay, so this is an ellipse. All right. That was relatively simple actually in this example. So we're going to say we know that this is an ellipse. Now that helps me with something. Even writing the equation of the equation, the equation of the conic section, it helps me with that even. Because I know what an ellipse formula needs to look like. Okay? Right now I'm not sure what's going on here. Alright? So let's figure out how to write this in standard form so that we can then go and graph it. Alright? So we know it's an ellipse. Let's write it in standard form. Okay? The way you do that is arrange the variable terms so that corresponding variables are next to each other, and then you complete the square. Okay? So I'll show you how that works. You do this, you say 4x squared. Here's an x term, so I'm going to put it next to the x squared. And then I put all the y terms together, there's only one. And then I'm going to put all the numbers on the other side. Okay, so there are none of our conic sections that are equal to 0, so I have to put something on the other side. So put the number on the other side. Okay, so put the x terms together, the y terms together, and the number on the other side. All right, and then complete the square. Now this is already squared. It's just y squared. I don't have to do anything there. That's already a squared term. It's perfect. It's a perfect square. But this is not, so I have to complete the square. Now the trick here comes in remembering how to complete the square. So how do I complete the square? The way you complete the square is make sure that the coefficient of the squared term must be 1. It's not. It's 4. Okay? So what you have to do is factor out 4. Alright? Like this. Alright, I did that. And then complete the square. So how do you complete the square? I do this. I say 4 times x squared minus 2x plus something, okay, plus y squared equals 8. And then I have to, because I'm adding something here, I have to add something here. Okay, that's how completing the square works. Now this is very tricky. What do I do? Completing the square, it's half of b, half of this thing squared. So half of -2 is -1 squared, which is 1. Okay, and let me do this in a different color. I should probably use a different color there. So what I'm doing here is adding 1. But now careful, I can't add 1 here. That would be a mistake. Because remember how this works. I'm adding 1 in parentheses. So I'm actually adding 4 times 1. So I'm actually adding 4 times 1. Okay, 4 times 1 is what I'm actually adding, which is 4. Alright? But we can proceed now. We've balanced the equation. Whatever I added here, 4 times that, I'm adding it here. So I've balanced the equation. Okay? And now we can proceed. Oh. I'm starting to erase all my writing. Okay? So now I can proceed. So, what do I get? What do I get then? I get 4 times... And you hopefully can see how this factors. Now you should know how this factors easily, but it's making it a perfect square, x minus 1 squared. Okay. And then plus y squared equals, and then 8 plus 4 is just 12. Okay. So you're going, hey, I got 2 square terms, I completed the square, what now? Well, this is not really right yet because it's not standard form for an ellipse or any of our conic sections. None of them look like this, okay? if you got equal to 12 here, and this is a radius of a circle, then these must be exactly the same coefficients for those terms. They can't be different like that, okay? And so what I have to do then is say, can't have 12 here, it's an ellipse, so I have to divide by 12 to make this standard form, okay? And if you do that, what you get is, this cancels, so I get what? X minus 1 squared over 3 plus y squared over 12 equals 1. Okay? And then I have my conic section. Alright? Now what I'm going to do now, because this video is already so super long, I mean, I don't know what else to say. This is how much content there is in the section. But what I'm going to do is, since this is the hard part, I'm not going to go graph it right now. Okay? Graphing it is not that tricky. We did a whole bunch of those graphing examples together. But finding the equation, that's a whole nother beast. Okay? So this one here, again, I'm not going to graph this. There is a completed note sheet for it. The question is, identify the conic section and graph it. Graphing, it's not that hard, but what conic section is this? That might be hard for you. Well, there's only one squared term. So I know this is a parabola. And since the squared term is a y, see if you can see this. Since y is squared, which kind of parabola is it? It is a horizontal, okay? Horizontal parabola, because y is squared. Alright, I'm going to stop there with this one. I don't want to do anything else here. I think you can graph that. That's not too bad, okay? All of this you can graph by yourself. It's mainly coming up with the equations. Here's another one. Here's another one. What's the shape of the path? This is actually the same as example 8a. It's actually the same kind of a question. What is the shape of the path? Meaning classify this conic section. What is it? So let's run through that recipe of ours again. Okay. The recipe up here said, now look at these square terms. Let me highlight them for you. 16x squared minus 9y squared. Okay, let's notice that and then walk through the recipe here with me. Okay, let's walk through the recipe. Only one term is squared. Nope, I have two squared terms. Okay, both squared terms are on the same side of the equation and they have opposite signs. Is that true? They're on the same side of the equal sign and they have opposite signs. Yes, they have opposite signs. So immediately I know that this is a hyperbola. Okay, that's what that little recipe says. It's a hyperbola. Check. I don't have to go on, nothing. I'm done at this point. It's a hyperbola. Okay, so I know it is a hyperbola. Okay, so then write the equation in standard form. This is the hard part. Graph the equation in the path. I'm not going to do that. I did two of them with you already today. Okay, but write the equation. That's quite tricky. All right. So let's do this one. So here's the equation. 16x squared minus 9y squared minus 96x plus 36y minus 36 equals 0. Woo, that's a lot of stuff. Okay. And so what do? Arrange terms, put the x's together, put the y's together, and take the number over to the other side. Alright? And now start completing the square. Remember, I've got problems. I got a 16 and a 9 there that I got to get rid of. Okay? So let's factor those out. 16 times x squared minus, this is 6. Thank the Lord that actually factored out. Minus 9 and then y squared. Now I'm factoring out minus 9, so this sign has to change to a minus 4y equals 36. Okay, and now we can complete the square, but now notice we're completing the square twice, but this is no biggie. You're okay with this. X squared minus 6x plus something minus 9 times y squared minus 4y plus something equals 36, and then I'm going to have a plus something here and maybe a plus something here. I think it's actually going to be a minus something here because I'm subtracting, okay, for the second completing the square. And so let's do it. Let's just complete the square. Half of negative 6 is 3 squared, negative 3 squared, which is positive 9. And then half of negative 4 squared is 4. Okay, half of negative 4 is negative 2 squared is 4. So what am I actually adding and subtracting on the other side? So let's see this again. Okay, 16 times 9. All right, so 36 plus 16 times 9. And then negative 9 times 4. So I'm subtracting 9 times 4. 9 times 4. Okay, which is 36 on both sides. Alright. And so if you do the math there, what do I get? Let's finalize the completing the square part. 16 times x squared minus 3 squared minus 9 times y squared. Oh, did I say y squared? Y minus 2 squared, okay, equals, and if you add all of this up, you get 144. 144. Now, we said this is a hyperbola. Yay! There's a minus, that's looking happy, but it's equal to 144. That's not a hyperbola. This is not standard form. Trouble, stranger, danger. So what you have to do is just divide that out. Okay? Divide it out and make it standard form. So if you do the division, I believe what you get is x minus 3 squared over 9. Alright, minus, guess what? 9 went here, 16 gonna go there. Y minus 2 squared over 16 equals 1. Okay, and now you have your equation for your hyperbola. And graphing that's the easy part. Graphing that is the easy part. We did a bunch of those today. Alright, so again, on the completed note sheet, if you still need to know how to graph this and you're struggling, no problem. I have it on the completed note sheet. You can graph it. You can ask me questions, okay? I hope this video helped you guys. It's a long section.